Welcome back. In this video, we will be discussing atomic masses. In the previous video, we learned that all elements have different isotopes, and all elements up to and including atomic number 83 have at least one stable isotope. We also learned in an earlier video that each element is displayed on the periodic table with its average atomic mass. In this video, we will see how the masses of each isotope of an element are used to determine the average atomic mass. The modern system of atomic masses was instituted in 1961 and uses the isotope carbon-12 as its standard. Carbon-12 was assigned a mass number of exactly 12 atomic mass units, or AMUs. Thus, all of the masses of all the other isotopes of carbon and all the other elements are determined by their mass ratio to this standard. For example, the mass ratio between carbon-13 and carbon-12 was found to be 1.0836129. Since the mass of carbon-13 is 1.0836129 times larger than carbon-12, then the carbon-13 isotope has an isotopic mass of 13.003355 AMU. The masses of all other isotopes are determined in this same manner. Now that we have the values for all the isotopic masses, we can use them to determine the average atomic mass of each element. Since carbon has two stable isotopes, the average atomic mass is based from these two isotopic masses. Since they are 12 AMU and 13.003355 AMU respectively, you would think their average would be approximately 12.5 AMU. However, when we look at the periodic table, the average atomic mass of carbon is 12.01 AMU. We failed to take into consideration the percent abundance of each isotope of carbon. When taking a sample of pure carbon from anywhere on Earth, we find that carbon-12 has a percent abundance of 98.93%, and carbon-13 has a percent abundance of 1.07%. Since the vast majority of carbon consists of the carbon-12 isotope, we must incorporate this percentage as a decimal value when calculating carbon's average atomic mass. Here's how we calculate it. The average atomic mass, AAM, will equal the isotopic mass of carbon-12, 12 AMU, times its percent abundance in decimal form, 0.9893, plus the same information from its other isotope, carbon-13, 13.003355 AMU, times its abundance in decimal, 0.00107. When we add these together, we find that the average atomic mass of carbon is 12.01 AMU. This equation can be utilized to calculate the average atomic mass of any element as long as we are given the mass and percent abundance of each of its stable isotopes. For example, what is the average atomic mass of silicon if its three stable isotopes have the following abundances? We have silicon-28, silicon-29, and silicon-30. They each have their own isotopic masses as follows: 27.97693 AMU, 28.97649 AMU, and 29.97377 AMU. They each have a percent abundance of 92.22%, 4.69%, and 3.09%, respectively. In order to calculate the average atomic mass of silicon, we use the same format that we used for the carbon. We just have to add the extra information for the third isotope. So for the average atomic mass for silicon, take our first isotope, isotope silicon-28. Remember to put its abundance in a decimal form. And then add the same thing for each of the other two isotopes. Once we have all of this information, we calculate that the average atomic mass for silicon is 28.09 AMU. Since the average atomic mass of all the known elements can be found on the periodic table, this equation can also be used to calculate the isotopic mass of any particular isotope given the other isotopes and all of their percent abundances. Simply fill in each variable and solve for the unknown isotopic mass. In our next video, we will show you how to do more of these calculations.